Welcome back. Today we will be talking about other types of equations, for example, the non-linear and the non-quadratic equations. When we are talking about the non-linear, we will be talking about the polynomials, and it will involve the quadratic and the cubic. So few things to remember: don't divide both sides by x or x squared, write in the journal on the standard form, and factor it if possible. So let's take this example. So I will rewrite this particular equation in the standard form, taking 48x squared on the left hand side. Once that is done, please factor it, don't divide by x squared. So factor out 3x squared, you will be left with x squared minus 16 in the parentheses is equal to 0. At this point, if you look at the equation carefully, this is in the form of a squared minus b squared. And we know a squared minus b squared is a plus b times a minus b. So we will rewrite it in the factored form. And once we get this, we can find the roots or the value of x. So if you put 3x squared is equal to 0, technically you will get two roots because it is x squared. X is equal to 0 and x is equal to 0. Because both of them are same, you just write x is equal to 0. But it implies two roots, which is repeated roots. And x plus 4 will give you x minus 4, and x minus 4 will give you x is equal to 4. Now we have these roots. Let's check. Always when you are solving these type of questions, always check. In this video, I will not check for every question. I will show you how to check in the first question. So when you are checking the answers, always plug it in the original equation. So let's plug one by one in the original equation. So let's plug first x is equal to 0. So anything multiplied by 0 is 0 only. So it holds true. Then let's plug negative 4. And if you use your calculator, you will find that right hand side is equal to the left hand side. So x is equal to negative 4 is also valid. And the same thing is true for x is equal to 4 as well. Now let's take another example in which we will be factoring by grouping the terms together. So this is called factoring by grouping. So for this example, let's take a cubic function. So when I say a cubic function, that means anything to the power of 3. So when the exponent is 3, that is the highest exponent is 3, that is the cubic function. So in this case, we have 4 terms. So we can combine the first 2 terms together and combine the second 2 terms together, and then we can factor it out. So from the first term, I can factor out x squared minus 3, and we can rewrite x minus 3 again. Then go back to the original equation and see how you can make the last 2 terms with x minus 3. So we can multiply by 3. If you multiply by 3, you will get 3x minus 9. We can complete the factoring by saying x squared plus 3 and x minus 3 is equal to 0. At this point, you will find the roots for x, or the solution for x. So the real number will be 3, but for x squared plus 3, we will not get a real number because it is a negative number. And whenever negative is involved, we are talking about imaginary, which is I. So you will get plus minus I radical 3, because negative 1 is nothing but imaginary number. And I is equal to radical of negative 1. Radical of negative 1, so we will get this particular imaginary number. Now, you can check this answer by plugging it in the calculator as well. So get yourself familiarized more and more often with the graphing calculator, because till now you have used only the scientific calculator. So on the graphing calculator, right on the top, on the left hand side, there is a y is equal to tab. If you click on that, you can plug in the equation, the original equation, which is x cubed minus 3x squared plus 3x minus 9. Once that is done, click the graph tab that is on the top right hand side. So these are the first two steps. Now the third and final step is to use this 0 function on the graphing calculator to find the x-intercept. And if you look at the graph, the x-intercept will be at 3. So the coordinate is 3 and 0. And that 3 and 0, this matches with our real number root that we just got. We got x is equal to 3, and that is also quite evident from the graphing calculator. That is your real number root. Now let's take one other example that involves quadratic. By looking at the equation, you might say, oh, it is not a quadratic, it is a fourth root, but we can rewrite the equation in terms of quadratic. Let's see. So let's take x to the power of 4 minus 7x squared plus 12 is equal to 0. Can I rewrite? We can rewrite it as x squared in the parentheses squared minus 7x squared plus 12 is equal to 0. Now if you see, x squared is behaving like a variable in this case right now. To turn it into a quadratic, we can consider it as a variable. So let's substitute x squared with a and make it a quadratic. So let x squared is equal to a, b, or whatever variable you want. So a squared minus 7a plus 12 is equal to 0. At this point, it is easier for us to factor it out and get the roots for the quadratic. Now it is a quadratic. I can factor negative 7a into negative 4a and negative 3a, and you will get the lovely roots as a minus 4 and a minus 3 is equal to 0. Now with that we will get a is equal to 4 and a is equal to 3, but that is not your final answer, because remember we plugged a for x squared. So let's plug x squared back. When you plug x squared back, you will get plus minus 2 and plus minus radical 3. And make sure you check your answer one by one by plugging it in the calculator. Do try this question on your own. Just follow the same steps that we did. Now the second type that involves a non-quadratic, that is radical. So keep a few things in mind. Square both sides or cube both sides. If it's a fourth root, then do the same thing. But remember, because we are talking about the radicals, do check your answer for any extraneous solutions. So for this particular problem, we will be taking into consideration the property of a plus b whole squared. So let's rewrite it to make our life a little bit easier. So what I have done, I have taken a radical x minus 3 on the right hand side and squared both sides, because now radical x minus 3 plus 1 is in the form of a plus b whole squared. So a squared plus 2ab plus b squared will give you this lovely equation. Let's combine the like terms. Let's clean it up a little bit more. So you will get x it should be x minus 5 plus 2, not minus 2. So that is why I got x minus 3 whole squared. I made that error. Because when you are taking negative 2 from right to left, it will be plus. So this again I squared it again to get rid of the radical, and this will give you a lovely quadratic. And we can factor the quadratic using our b and ac form. So you will get x minus 3, x minus 7 using b and ac form that we have discussed in the quadratic equations. So we have x is equal to 3 and x is equal to 7 as two answers. But remember, you need to check for any extraneous solutions by plugging it in the original equation. Not in the factored form, but the original equation. Let's take another example that involves radical exponents. For that, keep one thing in mind. If it is in the form of a to the power of mn, that means I can rewrite it in the radical. The denominator will become the index and the numerator is the power. So we will rewrite this equation and we will take cube both sides. So we rewrote it and we will take cube both sides. With this, what will happen? The radical on the left hand side and the cube, it will cancel out and you will get x minus 5 squared is equal to 16 cubed. Now I will take radical again to get rid of squares. So this will give you a radical of x minus 5 everything squared is equal to 16 cubed and squared. Now what is the radical of 16? Radical of 16 is plus minus 4. So we will write x minus 5 is equal to plus minus 4, but it is cubed. At this point, it is easier for us to solve and we will get two lovely answers. But remember, once again, do check the answers by plugging it in the original equation for any extraneous solutions. Now, the third type in this category is rational equations. Rational, the name indicates, that means something that is in the numerator and the denominator. Let's understand with this particular problem. So we have a fraction and a fraction. With those two fractions, if I plug the denominator equal to 0, so the two answers that can not be true for this equation is 0 and negative 3, because these will make the equation as undefined. So let's bring 3 on the left hand side, and at this point we can make the common factor as x times x plus 3. So the same way we make the common factors and multiply the numerators the way we do with the fractions. Let's clean this mess up. And we can multiply the denominator by the 0 on the right hand side, and that will become a 0 only. So we will be left with only with the numerator. So with the numerator, we will get 3x squared plus 15x plus 12 is equal to 0, and we can factor 15x into with using a b and ac form. So 12 times 3 is 36 squared and 15x. So two numbers that can added or subtracted together to get 15x or multiplied together to get 36. That will be 12x and 3x. So the same process again, combine the first two terms, factor it out. We'll get 3x plus 3 and x plus 4 is equal to 0. So with this you will get two lovely roots, which will be x is equal to negative 1 and x is equal to negative 4. Again, a reminder, do check your answer in the original equation. Now the fourth and the last type that we will be talking about is the absolute value. If you remember from your algebra 1, when we are talking about the absolute value equations, we are taking two cases, a positive case and a negative case. So I have listed positive case on the left hand side and the negative case on the right hand side. Let's solve it just like a simple equation and make it a quadratic, combine the like terms. Minus x minus 12 is equal to 0, and we can factor it out. If you factor it out, you will get x minus 4 and x plus 1 is equal to 0. With that, we will get two roots, x is equal to 4 and x is equal to negative 1. And we need to check it in the original equation. For the negative case, let's clean this up. has a whole lot of negatives. So be careful with the negative by distributing the negative to both the terms. And let's bring everything from right hand side to left hand side. Clean this up, you will get a quadratic. To solve this quadratic, I will be using a quadratic formula. So remember, the quadratic formula is minus b plus minus radical of b squared minus 4ac divided by 2a. I use the quadratic formula and I got the answer as a negative 9 plus minus radical of 33 over 2. I got a negative because there was a negative in the denominator with negative 2 and I brought that up. If you check the answers, I got the final answer after solving using both the answers in the original equation. I got the answer as x is equal to 4 and x is equal to negative 9 negative radical 33 over 2, because the rest of the two answers were extraneous solution. So the key for these things is practice, practice, practice. And I will see you in the next video. Bye-bye.